Okay, guys, what we have here is a limit as x approaches -3 of x cubed plus 4x squared plus 7x plus 12 divided by x plus 3. If we try direct substitution, we will end up with something undefined because we will get a 0 on the denominator and we have something divided by 0, so we will have undefined. So what we have to do here is try to factor. How can we factor this? We cannot factor using factoring by grouping, the traditional one, right? If we try to do this factoring by grouping, let's see what happens. Between the x cubed and the 4x squared, I have two x's in common, right? And then I will have x plus 4 here inside the parentheses. And then I have plus, but what can I factor between 7x and 12? They don't have anything in common. So here is the problem. This part is the problem of my common factoring, right? So how can I factor this expression? I can factor this one by using the method called Ruffini. Okay, so I have to use Ruffini here, right? So what is the method? What does the method of Ruffini says is that I have to take a look at the last term of my polynomial, right? And find the multiples of this term. So I know that the multiples of 12 would be 3 and 4 and 1 and 12 and 6 and 2. Those are the multiples of 12, right? But how can I identify which one I have to use? Which one of these I need for this factoring? Since I use factoring to get rid of something or to simplify something with the denominator, I can see that I have a 3 here, right? And I also have a 3 here. So I may use the 3. But since I'm using Ruffini, remember that when we talk about Ruffini, we will use the roots. Okay, so that means that here I have in factored form. So for the Ruffini method, I will use the same number, but with different sign because that's the root. Okay, so what is the next step? Is to copy all the coefficients of the polynomial. So I have here, I know that here I have a 1, so I can copy the 1 here, then I have a 4, then I have a 7, and then I have a 12, right? I have all those coefficients from the polynomial, right? And what does the method says? That I have to copy the first number here, and then I have to start multiplying. I have to multiply this times this, multiply, right? And the answer of that multiplication will come here. So that means that the -3 will be here. And then I have to add these two. So 4 plus -3 will be 1 again. And I repeat the same process. I have to multiply with the 3 and then put the answer here, right? So that would be -3. And this would be 7 plus -3, that would be 4. And then I repeat the same process. I multiply, right? And then I have to copy the answer here, right? So I will get a -12 there. And then I have to add these two, so I will end up with a 0. That means that my Ruffini is correct. Now, how can I use the numbers that I have that I found on doing my Ruffini, right? So what are the numbers that I have to copy here? Okay, all the numbers I can rewrite the polynomial, but in factored form now using Ruffini. So what will come here? Now I factor the first term. I know that a factor is this 3 that I have here, this -3, but I have to rewrite that -3 into a polynomial, right? Or I have to rewrite it as a regular linear equation, right? So this would be x plus 3, right? So always with a different sign. If here is negative, then it comes here with positive, right? And what numbers will come here? Here I will have the result of my division, right? This would be 1, we can say 1x squared plus 1x plus 4. Okay, those are the numbers that I have here. And why I have x squared instead of x cubed? Because since I used Ruffini, what I'm doing is I'm factoring, I'm expanding this polynomial into two polynomials. So that's why if I multiply the first times the second, I should get this expression that I have here. Okay, now let's continue. I will have x plus 3 here on the denominator, right? And then I can do this. I can cancel these two, and I will end up with x squared plus x plus 4, right? And if I do substitution here on this new expression, I will get 9 minus 3 plus 4, and that should give me 10. That is the limit that I will find, guys. Okay, so let's do another example. I have here almost this very similar exercise, right? That if I do the plugging in here, I will end up with 0 on the denominator, right? So that means that I will get something undefined, right? So that means that I have to factor. But if I do factoring by grouping, these two have something in common, but these other two, they don't have anything in common, the 5x and the negative 6. So what would be the best method to factor this polynomial that I have here? I can use Ruffini. So I have to take a look at the last term and find the multiples of negative 6. So what numbers will give me negative 6? I can say I can multiply 2 times 3, 1 times 6, and that's it, right? Those are the factors. And I can use positive or negative for each one, right? Because I have a negative there. So one of them should be positive and the other should be negative, right? So I can use any of those numbers. But always I have to relate it to what I want to simplify. I want to get an expression very similar to this on top, right? So that means that I need to use the tree. I should work with these factors, right? One of those should be the correct factor. So the clue here is that if we have here with negative, for the Ruffini will come with changed sign because it's the root. Always the root comes there, okay? So this would be, here we know we have a 1, so we copy all the coefficients from the polynomial, but be careful, here I have a negative 4, and here I have a 5, and then I have a negative 6. Okay, so what is the next step? Is to continue with the Ruffini. First I have to move this term here, right? I copy the same number, and then I do the multiplication. Multiply and then copy here. That is going to be 3. So if I add these two, I will get what? Negative 1. Again, multiply, right? And then I copy here and I will get what? I will get negative 3. And here, if I add 5 plus negative 3, I will get 2. And if I multiply it again, right, I will get what? A 6. So that means that here I should get a 0, right? That means that my Ruffini is correct. Now I can copy the polynomial, but in a factored form. So here I have one factor. That means that this is x minus 3. Remember, when you copy this number as a factor, it's always with changed sign, okay? And now I have what? I will end up with a quadratic polynomial inside the parentheses, because this was cubic. Now I have 1x here, so x squared should be inside the parentheses. So that means that I will use these coefficients for each term, right? So the first one is 1, so this would be 1x squared minus 1x plus 2. Remember that the 1, we don't need to write the 1. I'm doing this just for you to understand that the 1 and the -1 are going here, right? This step. So then I have x minus 3 at the bottom, so I can simplify this too. Now I can copy what I have at the end is x squared minus x plus 2, and finally I have to do the substitution. So I will get here 9 minus 3 plus 2, so I will get what? I will get an 8 as a solution. So this is how Ruffini works, guys. Okay, and be careful, that's the best way to use Ruffini.